Hello all, this is a video where I'll go over the midterm exam because we missed so much time on Wednesday because of the computers. I'm going to make a video, you can watch the video and then I'll post the answers. So I'm going to go through, I'm not going to do everything, but I'm going to do most of the things that you would need. So you should be able to see that. I'm not going to fully make the data set, but on video because there's no point, but I'll talk my way through it and I'll post the full data set later. So I'm going to share my screen. And so you should be seeing the exam and the Excel data set. I'm going to do the exam all in Excel. So this is going to be question one. And question one is simply Americans eat an average, so this is the mean of 1.86 pounds of apples a year with a standard deviation of 1.3. And if you were to eat 16 pounds, this is my observation, 16.7 pounds a year, what percent of the population eats less than you do, or I suppose eats fewer apples rather than less apples? All right, so this is simply, I'm just going to use the Z table, the normal table, to work out. And so what my Z is going to be equal to is going to be equal to my observation minus the mean divided by standard deviation. So I'm 1 point, so this is going to be close to negative 1.46. That's as far as I can go. So I'm going to look in my tables. And so in my Z table, which of course is not opening because why would it open? All right. This is a bit of a pain. Well, I'll come back to that once it's opened. So the second one, Americans eat an average of, again, 1.86 pounds. Then I'm surveying, right? So I'm surveying and I have an N of 18 and a mean of that survey of 16.5 and then a standard deviation of 2.6. So sorry about this. I'm just going to try and open the tables again because it's just not showing me it. So tables. All right, that's good. So I can go back to the first one. So instead of 1.46, so 1.46 gives me a Z of 0.0722. So because it's negative, that's 7.2 less, right? Right now. So that's my standard deviation. So I've got to work out two things. I've got to work out the t-score and I've got to work out the standard error. So the t-score, I have an N of 18. So that means degrees of freedom 17, doesn't it? Because degrees of freedom 17, because of course I do N minus 1. So that's 2.11. So my t is 2.11. My standard error is simply equal to standard deviation divided by square root of n. So my standard error is 0.612. So my lower bound is going to be equal to mean, my mean, which is 16.5, minus bracket 2.12 times. So that's the lowest that I would predict, and the upper is equal to the mean plus bracket 2. So 17.7. 18.6 is not included in that, so I can conclude that they are different. So my best guess is equal to, simply equal to that, right? The mean of my survey. And I am confident they are different. That's question 2. Rename E2. All right. Question 3. Use an exam, create 2 new variables, the percentage of people between 20 and 34 and 35 and 50, summarize all the variables and identify the best measure of central tendency, create a histogram for one of those, and a pivot table organized by region. So let's go back. So first thing I'm going to do, I'm going to create a region 1 variable because I think when I create the pivot table, it will look better. So Midwest, that's Northeast, South, and then finally West. Right. There are a couple of ways of doing that. I'm just going to do it that way because it's quick and easy. So I'm going to call this young percent and then middle percent, the middle age percent. Right. It doesn't matter. I don't need to, I can use whatever names I want because of course I'm going to create my code book. So it doesn't really matter what I call them. Maybe 54. All right, so I've created those 2 variables. Now I'm going to simply work out this is percentage. Now it's percentage, so I'm going to do the age group divided by the total population, but then I'm going to multiply it, of course, by 100, and I'm going to put a $sign in front of that D because that'll make it easier when I do this. Yeah, yeah. See, so it's just slightly easier. And I'm going to highlight these 2 and put them in. Now I'm going to format these cells because I think they look a bit messy. I'm also going to click them so I can read the full names. Actually, I'm going to click all of the data so I can do that. So I can say, no, I don't. Yeah. All right. So that's all that done. So I've created these new variables. I'm going to then go to the data analysis toolpack. I'm going to do descriptive statistics. I can't include the new variable I've created. Click labels, click summary statistics, click OK. So I would report the mode here. I'd report the mode, but of course I wouldn't report it as 3. I would say south. Yeah. I'm going to use the median for population. I will use the median for the age groups. And really, there's not much difference. I probably could use the mean or median for the percentages. They're very similar, right? So I don't mind either which ones you do for that. So that's the summary statistics. I'm going to look at this data and nothing appears that odd, right? These all things look reasonably like the largest total population, that's California, that's reasonable. Smallest is probably Wyoming. Yeah, that's right. So the data looks as good as it should do, right? So now I'm going to make a pivot table, insert pivot tables from data, click OK. This is where I'm going to use my region 1, and I want the averages of the young people and the middle-aged people. But so I don't want sums. I'm going to make those changes to average. Yeah. So there we see. Yeah. Fairly easy. That's my pivot table. Yep. And the last thing is to make the see. Last thing is to make the histogram of 20 to 34-year-olds. So let's look at the summary date for 34-year-olds. So that goes from 17 to 28. So I'm going to do this going up in 17 to 28. So I'm going to do this first. Yeah. So I'm going to going up in 1% years. Histogram, put range. That's young. Yeah. Labels. Bin range. And chart output. Click OK. That's yeah. So there seems to be quite a weirdly skewed distribution. Let's have a look. So where is 29? Did I sort by the wrong thing? Oh yeah, what did the percentage? Let's have a look. Oh, District of Columbia is a lot older. That's kind of interesting. Now, you could argue District of Columbia is not a state, but I think it probably is still useful. So I'm going to keep it in, but I might take it out. I don't know why there's such a small age group. It might be something strange, but I'm going to keep this. I'm going to empty these bins here at the side. I'm going to get rid of that. I might do it in 2%. I might mess about, but I might check District of Columbia, but I think it's because it's not a state. That's probably why it's a bit odd, but it's up to you what you want to do. Bigger one. Young adults by state. I'm going to change this to change that. This is going to be 18%. I'm going to go through and change this for each one. So 18% to 19%. Going to do that for every group. Just change it through. I'm not going to do it now. So this is but yeah, you would be expected to go and make every change. I'm not going to do that because there's no point in you watching me do that again. But that's the histogram. That hist. And the final thing I'm going to do is I'm going to create a data set. So I have the NHL data. So this is organized by player. So I'm going to use people's name, of course, and this is public action, right? So of course I'm going to use their name. I'm not going to use year. Year doesn't vary. Remember, I've said this is data from 2020 to 2021. So there's no reason for a year variable. I'm going to do nation. I'm going to do team, age, games, which could be games played, goals, and saves. So then I'm going to fill this in. So the first person is Connor Hellebuck. I have no idea who that is because I have no idea about ice hockey. So with nations, I'm going to create a code book now. Player name. Then nation is going to be nationality of player. And what I would do, because there are repeats, or there may be repeats, oh, there are repeats, there's Canada. I'm going to just do 1 equals USA, 2 equals Sweden, 3 equals Russia, 4 equals Canada, 5 equals Germany, right? I'm just going to fill that in team. This is team played for. Now, again, these could repeat, so I'm going to code these, but you maybe don't have to. I don't understand ice hockey enough to know if they've multiple goalkeepers. I think I could guess what these names are, but I think that's Winnipeg, then Calgary. I don't know what TBL is. Oh, Tampa Bay, I suppose. That doesn't seem to be much ice there, but I suppose you don't really need ice. 4 is, of course, St. Louis. Oh, you know, 5 is, I assume, Colorado, and 6 is, I assume, Pittsburgh. But I don't know, and so I'm not going to make a judgment of those. Age, this is, yeah, games. Number of games played in. This is, and this is where it'd be interesting because goals could mean goals scored, but it's actually goals against, and then number of saves. Right, so I would just fill these in. Team 1, age 27, games played 45, goals 112, saves 1, 2, 2, 3, and then I've got to create a new variable. So I'm going to saves per game. All right. So that's simply going to be equal to saves divided by games. So this player made 27 saves per game, right? I'd fill all of that in. Then I would do the summary statistics. I'm not going to do this because it's just me typing in data, which I will do, and I'll post it. The one I'm working out, the measure of central tendency, nothing for the name, of course. Nation, I would go with the mode, which I assume is Canada. Team, I would go with the mode, but I don't think there is a mode, so I would just leave that. Age, I would go with mean or median, depending if they're outliers. Games played, I would go with mean or median. Goal against, I would go with mean or median. Saves, I would go with mean or median. And all of those would depend if there are very big differences between them. Otherwise, that's it done. All right, so I will post this video and I'll post the answers and I'll see you all on Monday. And I hope our computer works. All right, so I'll see you soon. Bye-bye.